Hey guys, welcome to part 2. We're going through chapter 3, section 2, so 3.2. So I just talked to you about how to clear fractions. Now in this section, I'm going to tell you how to clear decimals. This is actually not too bad. So to do this, so it's kind of like the idea of figuring out what you need to multiply by, but there's actually a big shortcut we can take with it. So the idea behind this is that you want to count the maximum amount of decimals. So in this case, if you look at this, this is using, for instance, 2 decimals, 2 decimals, 2 decimals. So after you have done that, so in this case that would be 2, then move every decimal that many spots. So what this is doing effectively is this is the equivalent of really multiplying everything by 100, but we can really kind of just streamline the process by thinking of it as just moving decimals. So in this case, I'm going to move this decimal 1, 2 spots to the right. I'm going to move this one 1, 2 spots to the right, and then this one 2 spots to the right. So now what my problem will become is 3x plus 4 equals 19, and then this is all you have to solve. So you can just go ahead and subtract off the 4, you get 3x equals 15, divide each side by 3, and you get x equals 5. So that's the idea, and then there's nothing else that you actually have to do with this. That's really it. So clearing decimals is just very straightforward. Like I said, usually it's really you are multiplying things by 100, but what effectively happens is you can really think of this as an argument for moving decimal spots. So what I want to show you now is just one more example, so let me write that out. Okay, and so now if we do the same thing, it's 2 decimal spots. So go ahead and write the problem down and maybe just make sure you can count how many decimal spots that you've got. And so you'll notice here that the maximum amount of decimal spots here is 2. So notice now when I move all of these, so I move this one 2 spots, I have to move this one also 2 spots. So what do you think goes in the empty spot? A 0, yep. And then here, move those 2, move those 2. So you move all of them, right? So now I have the problem 5x plus 10 minus 3x equals 8. And so this is now what I have to solve, and then I just solve as usual. So this becomes 2x plus 10 equals 8. Subtract off the 10. I get 2x equals negative 2. Divide each side by 2, and I get x equals negative 1. So this is actually a much quicker method to kind of use. So that's all that we've got to talk about with that one. So what I want to do maybe is just do a few more examples using this technique. So let's go to the next page and I'll give you a few more. Okay, so let me write out another problem for us. And so this will work very similarly to fractions. So go ahead and write it down and look it over. And as far as moving the decimal goes, it's still the same idea, right? So we still think of this as kind of being like parts of a problem. So we have this part and this part and this part. So we only have to move that decimal once. And in this problem, I've only used 1 decimal spot. So I'm just going to move these decimals, and then that's really going to be it. So I can rewrite this problem now as 4 times x plus 2 minus 3 times 2x plus 1 equals 9. And so from here now you should be able to just distribute and finish it. So I'll go ahead and just show you what the solution here looks like. And so I've got all the work up here, so you can just compare your work to mine, but you should be getting x equals negative 2 as your solution. Okay, so let's do another one. So I'll clear some space here. Okay, so I've got one more. There's a little bit of something that makes this a little bit trickier, so I want you to pause the video, hit play when you're ready, and just be very careful when you try this. So in this case, the maximum amount of decimal spots that are being used here are 1. So as I kind of move down each part of the problem, so I move these, but remember, it's every single part. So this, and this, every part of it has to have the decimal moved. So the decimal here for the 2 is technically here, so I'm going to move this over 1 spot and fill in a 0 there. So that's like the little plot twist, I guess, if you want to think of it that way. So I've got this, and so now I can go ahead and finish solving this. So I'll write out the rest of the work. And so I get x equals 16 as my solution. So that kind of covers this technique. So I will show you just a few more examples on the next page if you just want a few more. And in the next video, I'm going to focus basically on working with fractions. But let me just kind of clear out this topic. So if you feel good, you can stop the video here. If you'd like to try this just a few more times, let's go to the next page and try some more examples. Okay, so I have another one of these problems. This one's a little bit of a doozy. So if you want to give this a try, hit pause and then hit play when you're ready. So for this one, so it's the same idea, right? So I'm going to move all the decimals one spot. And remember, for this 2, so technically this is a 2 with a decimal here, so this is going to turn into a 20. And then the rest of these decimals I will move as shown. So this is now going to turn into 4 times 2 minus 3x plus 20 times 2x minus 1 equals 7 times x minus 3 plus 7 times 4 plus 3x. So now I'll go ahead and just distribute everything so that you can see the next part of this. So I need to give myself a little more room, so I'll write over here. So now from here I can collect my like terms. And now you might be starting to see how this is actually going to work out. So if I subtract off the 28x from each side, the 20x's are going to drop out. I'm left with negative 12 equals 7. So this means that we actually have no solution. Okay, so I'm going to do one more problem in this video. So let me make some space. Okay, so here's one more problem for you. So once again, give it a try, hit play when you're ready. Okay, so I need to move all my decimals one spot. So one more time. Remember, for this x, there's actually an invisible 1 in front of it. So I'm going to move that decimal. So this is actually going to turn into 10x. So that's why I chose this problem, just to kind of keep you on your toes. And so now, if I write this out, I get 3x minus 6 plus 10x minus 2 will equal 6x minus 8 plus 7x. So now let me collect my like terms and just show you the rest of the work here. So what you're going to find is that each side is equal to itself. So the interpretation here is that there are infinite solutions. Okay, so that's all the examples I have for this one. In the next video, I'm going to go through way more examples with fractions. So I'll see you in the next video, and thanks for watching.